Okay, so I would like to say good morning to the sir and to everyone. I am Shavina, son of Jensen Indran, and I am behalf of Group 1 for this SCL Algebra assignment. So, for this, I have done question 5 and 9. So, I will explain about how did I solve question 5, which is related to about relations. So for question 5, they have asked three questions A, B, and C. So we will see one by one. So for A, they said that let R be the relation on Z where all AB is a subset of Z. A R B if and only if modulus A minus B less than equal to 2. So is R reflexive, symmetric, or transitive? Okay, so we need to prove one by one. Okay, as we see, so if reflexive means we need to show that ARA is true, right? So that means we need to write A minus A. So since A minus A is equals to modulus 0, obviously modulus 0 is equals to 0. Since 0 is less than equal to 2, so obviously ARA is true for all A subset of Z. So that means R is reflexive. Now we check whether it's symmetric or not. Okay, so for symmetric, so that means if A are B, then B are A. That means, so we need to find the BRA. That means modulus B minus A. Since in B minus A, we can change it in the version of negative A minus B. In modulus, if negative, it will become positive, right? So the negative is changed to modulus A minus B. So since A minus B less than equal to 2 according to the question, so that means the modulus B minus A, we get modulus A minus B. So both are equal. Set those, so that means modulus B minus A is also less than equal to 2. So it is shown that if A are B, then B are A for all AB subset of Z. So it's shown that R is symmetric. Okay, let's go to C. Okay, for this question, for transitive, we cannot prove using the previous one, using the properties. This one sometimes we need to assume the values. So but we need to make sure the values is a bit nearer to each other and then less than equal to 2. So for example, we choose A equals to 0, B equals to 1, and C equals to 2. So since A minus B, so that means modulus 0 minus 1. So that means 1. So since 1 is less than equal to 2, A or B is true. And then we check for B minus C. So that means 1 minus 2. So that means 1 less than equal to 2. So it's also true. For A minus C, so 0 minus 2. So that means 2 less than equal to 2. So it's shown that all three statements are true. So it means it's shown that if A are B and B are C, then A are C for all A, B, C subset of Z. So that means R is transitive. So since we have proved that the all this R is reflexive, symmetric, and transitive. Okay. Okay, that's all for question A. Now we can move to question B. Okay, for this one, they said that let for this one, they said that let R be the relation of Z where all A B subset of Z. So A R B if and only if A is a multiple of B. Is R reflexive, symmetric, or transitive? Justify all conclusion. So this question we have seen in our tutorial, but this a bit it changed the type of question. So for reflexive, so as usual, we need to show that if A or A is true, if and only if A is a multiple of A. So that means we need to show that A is multiple of A. That means so A is equals to A. We know that, but we need to write in this form: A equals to 1 times A. So since A divided A, we get a whole number. So it is shown that A is a multiple of A. So then we need to conclude that A or A is true if and only if A is a multiple of A for all A subset of Z. So that means R is reflexive. Okay. Now for symmetric. Now, okay, for symmetric, this case we need to assume. Okay, so for this one, we let that A equals to 4 and B equals to 2. Okay, some questions for symmetric or transitive, we need to do assumption. Either each one or both also we need to do assumption. As long as we get the right solution, we can use any method. Okay, so for A or B, right? Okay, we choose A equals to 4 and B is equals to 2. So we can write the 4 is equals to 2 times 2. So we divide 4 divide 2, we'll get 2, that is whole number. So it is shown that 4 is a multiple of 2. Okay, so ARB is true. But besides for BRA, so if we 2 divide by 4, we will get 1 over 2. It's a rational number, not whole number. So that means 2 is not multiple of 4. So BRA is not true. Since BRA is not true, if ARB is true, so that means it's not symmetric. Every time you guys write this, you need to write that the final conclusion and you need to state whether it's symmetric or not. Okay, for final, for transitive, this one we can use the algebra method. For example, like substitution and properties. Okay, we need to show that if A or B means A is a multiple of B, that means B times any whole integer, we will get A. So we will assume that the integer is M. A equals to BM. Same goes to BRC. B equals to CK. We assume that C times any K is in integer, we will get B. So since here also got B, here also got B. Here the B, right, we will replace with CK. So uh, A is equals to CKM. So we separate the C and then we bring the M into the bracket. It's KMC. So okay, um so this KM is, we assume that it's an integer and it times C will get A. So it is shown that A is a multiple of C. Okay, so now we need to conclude. It is shown that if A are B and B are C, then A R C is true for all A B C subset of Z. So R is transitive. Okay, shall we move on to the next question? Okay, B and C around same question only, but the way they ask is different. For B question, they said A is multiple of B, but this case they said A is a factor of B. It's a different, same method but different way. So same for, if A is, so for reflexive, we need to show that A is a factor of A. So that means A is equals to A times 1. So A over A, we will get 1. So it's a whole number. So that means it is shown that A is a factor of A. So A or A is true for all A subset of Z. R is reflexive. We need to remember that all numbers are factor to themselves. And then now we move on to symmetric. If A are B, then B are A. Okay, so let A be subset of Z. This time we assume inversely. That means since A is a factor of B is true, right? So that means we assume that 2 is a factor of 4. We know that, right? So we assume A equals to 2 and B equals to 4. So to prove that, we divide 4 divide 2. We will get 2. That is whole number. So it's shown that 2 is a factor of 4 and then A or B is true. In contrast, so we will show that B is not factor of A. So that means we will divide 2 divide 4. It will get a rational number. That means 4 is not factor of 2. So BRA is not true. Since BRA is not true, so R is not symmetric. Okay, for transitive, we use the same method. Okay, for multiple, we will use A equals to M, but for this one, A is a factor of B. That means if A times any integer, we will get B. For example, if 6, right? So 3 is a factor. So 3 times 2, we will get 6. Same goes here. A times any integer, we will get B. So same goes BRC. B is a factor of C. So B times any integer K, we will get C. So we will replace B with AM. So C is equals to K bracket AM. So KMA. So we bracket the KM and with A. So we will assume that KM is any integer times C, we will get C. So A is a factor of C. So since ARB and BRC is true, then ARC is true. So R is transitive. So that's all for my part for this question, for this question 5. So thank you, sir, and thank you everyone for listening this presentation. Thank you so much.